In this video, we'll be looking at problems from section 3.3 on page 218. You have odd problems to do. I'm going to do some even examples. First, number 2. Number 2 asks for f of 3. Well, this is function notation, and we went over this in class. The function in question is f of x equal to 2x minus 5. When we say f of 3, we're simply going to take 3 and substitute it into both places where we see x. Here you see x has become 3. Alright, so 2 instead of x, I'm substituting 3. Subtract 5. Well, 2 times 3 is 6, and 6 minus 5 is 1. So we say that f of 3 is equal to 1. This statement here is analogous to the statement y equals 2x subtract 5. Alright? We call this function notation and this equation notation. Here we use the notation f of x, and here we use y. So you can think of f of x as being y. And this statement here, f of 3 is equal to 1, is analogous to the ordered pair 3, 1. This is saying when x is 3, the associated y value is 1. This is saying when x becomes 3, the function maps to 1. F of 3 goes to 1. These statements are analogs. They're very similar to each other. Alright. Next, number 4. Number 4 deals with the g function, so let's start there. G of x equals x squared plus 3x plus 4. First, this f and g on the outside here, it's just simply the name of the function. It could be a, b, c, d. It doesn't. It's totally arbitrary what these letters outside. It's just a way for us to distinguish between these two. The variable inside the parentheses is going to be our independent, our input variable. So it could be g of m. In this case, we'd have m's over here, or g of b, and there would be b's over here. So the letter outside is the name of the function, and the variable inside is the input variable, the independent variable. Alright. So we're looking at g of negative 2. We are simply going, as they have taken x and changed it to negative 2, we're going to substitute negative 2 in place of x on the right side here. Alright, so I've substituted negative 2 in place of x in both of those locations. So we say g of negative 2 is equal to negative 2 quantity squared, that's 4. 3 times negative 2 is a minus 6 plus 4. So 4 minus 6 is a negative 2 plus 4, that's a positive 2. G of negative 2 is equal to 2. Again, that's like saying negative 2 pairs with 2. Alright. Number 14. Again, I'm doing the even numbered problems. They should help you with your associated odd numbered problems. Number 14. They ask for g of 0. And in these problems, they defined g of x to be 2x minus 1. So to find g of 0, we are simply going to substitute 0 in place of that x. So 2 times 0 is 0, minus 1 is negative 1. We say g of 0 is equal to negative 1. Alright, next let's look at problem number 18. g of negative 1. Again, I'm going to substitute into my g function, which was g of x equals 2x minus 1. I'm simply changing both of these x's to negative 1. G of negative 1 is 2 times negative 1, subtract 1. Well, 2 times negative 1 is negative 2, minus 1 is negative 3. We say that g of negative 1 is equal to negative 3. Alright, that's 18. Now let's look at problem number 26. In 26, they give us two mappings. They say that function f is 1 pairs with 4, negative 2 pairs with 0, three pairs with a half, and pi pairs with 0. Alright, first let's verify that it meets our definition for function. You notice that each x only pairs with one y. There are no repeated x's here. So f, the relation f is indeed a function. And they define g to be 1 pairs with 1, negative 2 pairs with 2, and 1/2 pairs with 0. Again, g is a function. We have 1, negative 2, and 1/2. No repeated x's. Each x pairs with only one y. Both f and g are functions. Alright, so I'm going to look at 26. 26 asks for us to find g of 1. So all it's asking is when the input is 1, what is the output? Well, here you see that 1 pairs with 1. So g of 1 is equal to 1. As I said before, this notation is analogous to 1 pairs with 1. And here you see it. 1 pairs with 1, the g of 1 goes to 1. Alright, now looking at number 28. They are asking, what is f of 3? F of 3 equals what? That's the question. Well, that's analogous to saying, hey, when x is 3, what is the associated y value? Alright. What does 3 map to? 3 pairs with what? Well, going to our f function, 3 pairs to 1/2. So we say that f of 3 is equal to 1/2. That is similar to saying 3 pairs with 1/2. This is our answer for number 28, and this is our answer for number 26. Alright, with those examples, you should be able to complete 3.3.